So I'm going to consider this question quickly as part of our revision. So there we've got an inverse function, which is our hyperbola. We are given the following is an incomplete table of values for that function. All right, so you must answer everything, all this on a sheet of graph paper. Okay, so calculate the value of P and the value of Q from this information. All right, so here it was simply substituting the values, all right, that were given for X. For P, X is what? 5, substitute X there. So that's y is equal to 12 over x, which is what? 5 minus 1. So that is going to give us the value of y there. So 12 divided by 5. All right, that's something like 2,4. 2,4 minus 1, which is 1,4. All right, so this was going to give us 1,4, the value of p. And q, when x is what? 8. Substitute 8 in place of what? In place of x. All right, so this is what you're going to simply do. Our x this time is what? Is 8. So I'm going to put 8 here. So that's y is equal to 12 divided by 8. Then subtract 1. It was going to give you 0,5. You can also just use a calculator, guys. This is paper 2. Do not limit yourselves. All right, minus 1 like this. So that's a half, which is what? 0,5. So that's the value of Q, 0,5. Okay, then on B, using a scale of 2 centimeters to represent 1 unit on the x-axis, all right, and 2 centimeters to represent 2 units on the y-axis, draw this graph for x values taken from 1 up to 8. From 1 up to 8. As you can see, our x values, they are positive. All values here are positive. All y values are also positive. So we do not have negative values, guys. So there's no need for us to divide our graph like this because we do not have negative values. We can be more positive. That's take our graph so that it becomes what? More positive. You can even start here, guys, straight from the starting point here. And this one also, since we do not have, all right, sorry for that. Since we do not have the negative values, we can also take it down here to the starting point. All right, we can have our line on the starting point because we do not have anything on the negative, guys. All right, so this is it. We can actually have our Cartesian plane in this manner. All right. So with our Cartesian plane, let us represent our values as we are given. In the x-axis, we must have our values from 1 up to 8, all right, using what? 2 centimeters to represent 1 unit on the x-axis. This is the scale that you're given, 2 centimeters to represent 1 unit. So this is 0. After 2 centimeters, 1, 2, 3, 4, 5, 6, 7, 8. All right, you can just indicate 9, it's not a problem. So that's it on the x-axis. Then we move on to the y-axis. 2 centimeters there represents what? 2 centimeters to represent 2 units on the y-axis. But they are positive, and we must include 11 as our maximum value there. As we can see, all values are positive. So we must just take up to 11, 2 centimeters to 2 units. So this will be 2, and that will be 4, and this is 6, and that is what? 8, okay, and that's 10, okay, and this is going to be 12. We have accommodated what? We have accommodated 11 in that case, all right? So this is it. So that is every, after 10 boxes, 1, 2, 3, up to 10, 2 units. Here, 10 boxes, 1 unit like that. So this is how it was going to look like, and we just need to fill in our values, all right? 1 versus what? 11. When x is 1, y is 11. So this is 1 and 11 is going to be up in between 10 and 12. All right, this is where we've got our 11. So 1 versus 11, where they meet, you mark a point. So that was going to be somewhere here, 1 versus 11. Okay. Then 2 versus 5. All right. 2 versus 5 in between 4 and 6. That's where we've got 5. So this is 5 here. So 2 versus 5. That is going to be this point. All right. And 3 versus 3. Okay, 3 versus 3. 3 is here in between. This is our 3. So that's 3 versus 3. We mark our point. And another one, 4 versus what? 2. So that's 4 and 2, where x is 2. Okay. Then 5 and 1 comma 4. All right. So here we must be careful, guys. 1 comma 4 in terms of values in the y-axis. 2 centimeters represent 2 units. So meaning to say each box represents 0, 0,2. So that's 0, 0,2. On the x-axis, each box represents what? 0, 0,1. 0, 0,1 up to 1. So here we need 5 versus what? 1, 4. So let's locate 1 first. 1 is in between what? 0 and 2. So this is 1. So this is 1 here. So where do we have 1, 4? So after that, we count 0, 2, 0, 4, and so on. So this is 1. So that's 1, 2, 1, 4. So 5 versus 1, 4 was going to be this one. Okay. Then 6 versus 1. This is 6, and this is where we've got our 1 in between 0 and 2. Okay. Then 7. Okay, we move on to that one according to our points. Here it was 7 versus 1. Okay, so now, guys, okay, it's here 7 versus 0, 7. All right, 0, 7. So remember, this is 7. So we have got 0, 2, 0, 4, 0, 6, 0, 8. So where do we have 0, 7? 0, 7, it's in between 0, 8 and 0, 6. In between these 2 points, that's where you're going to have what? 0, 7 in between those 2 points. All right. 8 versus what? 0, 5. So this is 8. This is 0, 2. 0, 4, 0, 6. So where do we have 0, 5? In between these 2 points, 0, 4 and 0, 6. So that's where we have got our 0, 5. So these are the points that we're simply going to use. Join these points, then you've got what? You've got your hyperbola, the inverse function. As we can see, it was found on one side of the graph. It's not like what we had before, where we are going to have another section on another piece, this and that. No, this one was just direct. All right, so here, guys, I'm trying to move my page. I do not know why is it not moving. Why is it stuck? I can only zoom. I can't adjust. I do not know, guys, what just happened. Okay. Don't know, guys, what just happened. Okay, no problem. Let me just join it here. I hope you understand me. Maybe it's gonna change later on. You never know. These softwares, they can just misbehave when they want to. Okay, so you must join and have smooth curve later. Let me try these ones that are a little bit closer. So guys, you must have a smooth curve, all right? So you must have a smooth curve more than this one that I'm having here. This is not smooth. Here I'm just showing you an illustration so of how it was gonna be like. And you are supposed to have something that is very smooth, guys. More than this. All right? Something like this. So this is our hyperbola. So like I said, guys, produce something that is smoother than this one. So that's why is equal to 12 over x minus 1. Okay, that was the concept. So, okay, now it can move. You see, guys, these things, they just misbehave when they want. So that was it on this graph. Okay, then let us move on to another part. Okay, here what happened? Now back to maybe, okay, no, this is the one. So that is it. 4 marks. It was just simple. Then C, use the graph, all right, to find this. All right, why is it like it's a lot? 4, 8. All right, this was just supposed to be 2, like 2 marks, 2 marks. Yeah, 2 marks, 2 marks here. So yeah, it can make sense. Okay, anyways. We need the gradient of the curve where x is what? Where x is 2. So where x is equal to 2, that's our point of what? Tangent. Where x is 2. That's your point of tangent. So you must indicate that on the graph and your tangent must be drawn from that point. So that is it, where x is 2 to the graph. This is the point where y is what? 5. All right. Anyways, let us see. It was gonna be like this. This is our tangent touching the curve at a single point. That at a single point, just it just touches the curve. All right. So with this tangent, the point of tangents where x is 2, y is what? 5 must be indicated. So we're going to use the point 2 what? 2, 5. And you look for the second point, which is on the tangent, the straight line. Any point which lies on the straight line. We can take advantage of this one. It's a little bit visible, this one. 3 versus what? 2. So we can use the point 3 versus 2. When x is 3, y is what? 2. Any point which lies on the graph. So you start with the x value followed by the y value. Always a point, x versus what? X versus y. Okay, so using these 2 points, I can calculate what? The gradient. All right, so that was it on C item 1. So our gradient, I'm going to use the point 2, 5, the point of tangency, and the second point, 3 versus what? 3 versus 2. So you can name this x1, y1, x2, y2. So our gradient is simply the change in y over what? Over the change in x. So that's y2 is 2 minus y1, which is what? Which is 5 over x2, which is 3, minus x1, which is 2. So that was going to give us minus 3 over 1, which is minus 3. So that is basically the gradient of the given what? Function where x is what? Where x is 2. Just like that, guys. Simply use 2 points. Okay. Then the area on item 2, the area that is of the region between the curve. So we have the curve, this curve that we are given here. So that is the curve must be included. All right. So we need between this curve, okay, and what? The x-axis, we must have the x-axis on our area. The x-axis must be included, okay? And the lines x is equal to 3 and x is equal to 6. The lines x is equal to 3. This one, where x is what? 3, and where x is what? 6. So these are the lines. X is equal to 3, x is equal to what? 6. So which area are we going to refer that is bounded? This is the region here in between. You can see, guys, between all these lines and including the curve. So this is the region where your area was going to be calculated from, all right, up to the x-axis here. So you calculate the number of boxes, guys, as before, all right? Then you use them for the area. So approximately you're going to have something like 265 boxes. 265 boxes. So with these, I can calculate the area. All right, so that was item 2. So the area is going to be given as number of boxes, 265 boxes over what? 100 times the area of the unity square. So our unity square, this is 1 and this is 2. So according to 2 centimeters represents what on the x and on the y. So 1 times 2 is what? Is 2. That's the area of the unit square. Use your calculator, guys, or divide here. This is going to be 2,65 times 2. And that was going to give us 5,3 at the end. Okay, so that is 5,3 square units. Okay, just like that. So that is your area. That is your area. That is your area. Okay, let us see D. On the same axis, draw the graph of what? Y is equal to x plus 4. That's a linear function, a straight line. So you can use any method that you want, double intercept, table of values, one point and a gradient. It is up to you for you to draw that line, all right? So it is up to you guys, all right? Anything that you want, actually, you can simply use that. So double intercept was going to affect was another value was going to be a negative. So we do not have negative values, so you can actually focus on the what? TOV method, table of values, or one point and a gradient, all right? So using table of values, we're going to draw the line of what? Y is equal to x plus what? Y is equal to x plus 4. Okay, so let us quickly have our table here. So that was D. We must draw the line first of y is equal to x plus 4 using the table of values. 3 points are enough. So I'm just going to pick 0, 2, and so whatever that I want, 0, 2, okay, 4. Okay, 0, 2, 4. Let's see. When x is 0 here, 0 plus 4, that's what? That's 4. When x is 2, 2 plus 4, that's 6. When x is 4, 4 plus 4, that's 8. So you mark those points. Remember, guys, how to sketch a straight line. So that's 0 versus 4 on the y-axis, 0, 4. 2 versus 6, 2 versus 6. Okay, we have 6 here. So that's 2 and 6 somewhere there. You mark those points, 2 versus 6. Okay, and 4 versus what? 8. 4 and 8. 8 is here. They meet here. So that's 4 versus 8 was going to be somewhere here. So these 3 points, you can join them using a ruler. You have what? Your straight line. All right, just like this. So that was the question here to draw the line first. The line of y is equal to x plus 4. And after that, hence, solve the equation. Hence, solve the equation. Which equation are we solving? 12 over x minus 1, the original graph function that we drew before, is equal to x plus 4. These two, we are back, guys, when two graphs are equal, the first graph that we had and this one of y is equal to x plus 4. They are simply the ones that we are given here. They are equal. So when these two graphs are equal, guys, where do we have our solutions? At the point of intersection, where the two graphs what? Intersect. So these two graphs here, they intersect at this point. Where they intersect, what is the value of what? What is the value of x there? So this one was going to approximate to 1,8, somewhere there. 1,8. You take it straight using your ruler. So it was going to approximate to 1,8. So that is the x value. So therefore, x is equal to what? 1,8. This is the solution now to this equation and solve that. So the first was to draw the graph, then after you solve, which you consider from what? The point of intersection. Just like that. So it's all about revision. You see, guys, we have answered the whole question just like that. So it's all about revision. Let's do revise. All right? We're going to look into other revisions later.